Edward and Clara are both nurses. So Edward works a 10-day cycle, works the first 7 days, has 3 days off. Clara works a 7-day cycle. She works the first 5 days, has 2 days off. And they both start their cycles day 1 of week 1. Now notice that Clara, she's not really going to be any mystery. Every single week she's going to have exactly the same schedule. Every single week she's going to work day 1 through day 5 and then have day 6 and day 7 off. That's going to be the same from week to week. Edward is not going to be the same from week to week because he's on a 10-day cycle, so that's going to vary from week to week. So we have to map out how Edward changes, and then we can see when his days off overlap with Clara's days. Okay, so how does Edward work? What is his cycle? It's a 10-day cycle. He works the first 7 days. So the whole first week, day 1 through day 7, he works. Then he gets 3 days off. Then he works these 4 days, these 3 days. He gets 3 more days off. Now notice something interesting, that because he works 7 days, whatever the first day of that 7-day cycle is, for example, in week 2, the first day of the 7-day cycle is on day 4. That's the first day of the 3 days off in the next week. And so much in the same way, week 3, the first day of working at the beginning of the cycle is day 7. The first day off is going to be day 7 in week 4. The first day working in week 5 is day 3. The first day off in week 6 is going to be day 3. The first day working in week 6 after the days off is day 6. The first day off in week 7 is going to be 6. First day working in week 8 is day 2. The first day off in week 9 is going to be day 2. First day working in week 9 after those days off is day 5. The first day off in week 10 is going to be day 5. And so those are where his days off land. Where is he off at the same time as Clara? Well, Clara is off the last 2 days. She's always off day 6 and day 7. Well, they overlap here in week 7. They overlap here in week 10. And so those are the 2 weeks in which they both have the same days off, week 7 and week 10. Answer choices E and H. The first term in a sequence is 1. And for all the other integers, n greater than or equal to 2, the nth term is the sum of 1 plus the reciprocal of the previous term in the sequence. What is the value of the 6th term in this sequence? So we have to go through these terms one by one. So the first term is 1. Second term is 1 plus the reciprocal of the previous term. Well, that's 1 over 1, which is 1. 1 plus 1 is 2. So that's the second term. Third term is 1 plus the reciprocal of the previous term. That is 1 plus 1/2. I'm going to write this as a fraction. 2 halves plus 1/2 is 3 halves. The fourth term is 1 plus the reciprocal of 3 halves, 1 plus 2/3. So 3/3 plus 2/3 equals 5/3. The fifth term is 1 plus the reciprocal of 5/3, which is 3/5. Well, 5/5 plus 3/5 is 8/5. The sixth term is 1 plus the reciprocal of 8/5, which is 5/8. So 8/8 plus 5/8 is 13/8. And incidentally, these numbers that we're getting, 1, 2, 3, 5, 8, 13, these are known as the Fibonacci numbers. You don't need to know that, but this is an important pattern in math. Anyway, the sixth term, we have found the value of that, and that value is 13/8.
To begin, let's let x equal the total number of kilometers flown for this trip. We're told that the cost of any trip is equal to $85 for the first kilometer plus $5 times every kilometer after that. In other words, 5 times x minus 1. Now for this question, we're told that the total cost of a particular trip is $365. So we now have an equation to solve. We'll subtract 85 from both sides of our equation, and now we'll divide both sides by 5, and finally we'll add 1 to both sides to get x equals 57, so our answer is C. To calculate Clyde's average speed for the entire trip, we'll take the total distance that he traveled and divide it by the total time spent driving. Now the question tells us that Clyde drove for a total of 40 miles, and he spent a total of 30 minutes driving. Now notice that in column A we are currently comparing miles with minutes. However, in column B our speed is given in miles per hour. So before we go any further, we must take the 30 minutes in column A and convert it to hours. 30 minutes is equal to 0.5 hours. From here we can simplify column A to give us 80 miles per hour. When we compare this with column B, we see that column A is greater, so our answer must be A.
An interesting one by a sequence. Each term is divided by some positive number p. So if S3 is 24, S4, the fourth term, has to be 24 divided by p. And then the next term, S5, has to be this divided by p again, so that's going to be 24 over p squared. But we know that that equals 6. So multiply both sides by p squared, we get 24 equals 6p squared. Divide both sides by 6, 4 equals p squared. We know p is positive, so p is 2. So that's the value of p. And so that's easy. We're just going to divide by 2 to go from term to term. So we already know that S5, term number 5, equals 6. Term number 6 divided by 2, we get 3. Term number 7 divided by 2, we get 1.5. Term number 8 divided by 2, we get 0.75. And that is the value of the 8th term, answer choice B. The Sargon Corporation offers an optional stock option buy-in program to its employees. Of the employees with salaries greater than or equal to $100,000, 85% choose to participate. Of the employees with salaries less than $100,000, 77 choose to participate. Which of the following could be the total number of employees? Indicate all possibilities. So the first thing to keep in mind is when we have percents like this on a test problem. In the real world, 77%, that could be a rounded number in the real world. That might be 76.8 or 77.3, something like that. On the test, in the strange world of the test, that 77% is exactly, mathematically, 77%. And what does that mean? Well, 77%, of course we write that as a fraction, that's 77 over 100. So we could only have 77% of 100 or some multiple of 100. So we need a multiple of 100 to be able to take 77% of it. Meanwhile, 85 over 100, we can divide numerator and denominator by 5. 100 divided by 5 is 20. 85 divided by 5 is 17. This is the fraction 17 over 20. And so we don't need necessarily something a multiple of 100, but we do need a multiple of 20. We would need a multiple of 20 to have exactly 85% of it. And so the number of total employees must be some multiple of 100 times plus a multiple of 20. So 100 is not going to work, because if we have the 100, we can't add anything else to it. That's not going to work. 200 would work. That could be 100 plus 100. Multiple of 100 plus a multiple of 20, that certainly works. 350 doesn't work, because we could get up to the 300, but we can't get to 50 with 20s. So that doesn't work. 460, that would work. We could have 400 plus 60, or we could have 300 plus 160, bunch of different combinations. That certainly works. 525, no, there's definitely no way we're going to get to that purely with multiples of 100 and multiples of 20. 640, well, that would work. We could do 600 plus 40 or 500 plus 140, a bunch of different possibilities. So that certainly works. We can't get to 50. just adding with multiples of 20, we'd get up to 700, but we're not going to get to that 50 with a multiple of 20, so that's not going to work. And 880, this is going to work. This could be 800 plus 80. And so B, D, F, and H all work.